Let's look at the last example here, a nice application one. Again, this is real world problems. What am I thinking real world problems? I'm thinking we got to label our answers. And these are not going to be nice numbers because it is real world problems. This is not a joke. These are not made up numbers. These are real mathematical equations that have found for real stores, not fake stuff here. So it says from 2004 through 2013, the sales price per share S in dollars for Dollar Tree can be modeled by S equals 0.0120 t squared plus 0.140 t plus 2.30 quantity squared for 4 less than or equal to t less than or equal to 13, where t is the year with t equals 4 corresponding to 2004. So you're just entering the year number. Like 4 is 2004, 10 would be 2010, right? It says use the model to approximate the rate of change in sales per share in 2010. So again, they're wanting a rate of change, and they're wanting a rate of change at a point. If it's not an average rate of change between 2 points, that would be a slope, right? Just find the slope. It's a rate of change at a single point. Because it's a single point, we need to find the derivative. So what are we going to do? We're going to find S prime of t. And then the second thing we're going to do is we're going to look at it at t equals, well, they wanted it in 2010, and by reading it, we know that 2010 is when t equals 10. Okay, so let's go ahead and find that derivative. S prime of t, well, it looks like a quantity raised to a power. Again, we have different ways of doing this. We could sit here and we could distribute it out, which would be horrible, but we could do it. Or we could just use the general power rule. General power rule says drop the power. That's the 2. Keep the inside exactly the same. So that's 0.012 t squared plus 0.14 t plus 2.3. I don't know why they put all those zeros there. To the quantity minus 1. So the 2 minus 1 is just 1. But then we need the derivative of the inside. So we need 0.012 t squared plus 0.14 t plus 2.3 prime. Let's think about the derivative of that. 0.012 t squared would be, the derivative of that would be 0.024 t. Just drop the 2, right? Power minus 1. The derivative of 0.14 t would be plus 0.14. And the derivative of 2.3 is 0. So what we have now is S prime of t equals 2 times 0.012 t squared plus 0.14 t plus 2.3 times 0.024 t plus 0.14. Okay. Usually we'd have to simplify this a little bit, multiply things out, but who cares? We do not care about the derivative. That is not our final answer. We need to look at it at t equals 10 is our final answer. So I don't care about simplifying whatsoever. We are just plugging the number in. Let's do it. So this would be 2 times 0.012 times 10 squared plus 0.14 times 10 plus 2.3. We're going to multiply all that times 0.024 times 10 plus 0.14. Throw that into your calculator and let's see what we get. Not saying it's nice. Again, real problems mean real ugly numbers. I'm getting S prime of 10, the rate of change in the year of 2010, approximating by 3 decimal places. I'm getting 3.724. Please verify and make sure you're getting the exact same thing as me. If I made a little error, I apologize. But again, I want you to think about this. When we find the derivative, we're finding the derivative of the sales with respect to t. So we always do this because we want to think about our units here. Derivative of sales with respect to t. So sales were the dollars per share is what S was. And then time here was measured in terms of years. So what in the heck did we just get? We just got 3.724. So I'm going to approximate this because this is dollars, so we should probably do cents. So we just got $3.72 per share per year. Okay, that's what we just got, is $3.72 per share per year. So what does that mean? They should expect an increase by $3.72 per share from 2010, the start year, and it's per year, so that would be to 2011. Again, that is not the price per share, that is the increase in the price per share. So the actual share price might be $100 in 2010. If it were $100, then in 2011, we would expect it to be $103.72. So that's what it is. This is not the cost per share. This is not the price per share. This is the increase in the price per share. So this is how much has changed, not the actual cost, just how much it changed in that year. That's what the derivative is. So now that we have these rules, we have the sum of putting it all together. We have truly all the rules, the vast majority of the rules, not all of the rules, but the vast majority of the rules and skills that you need to use differentiation. And differentiation is what's primarily on the first, second, and third test. There's only one test in this class that doesn't have differentiation. The final exam has it as well. So these are the rules that you really, really need to be comfortable with. Again, the derivative of a constant, like what's the derivative of 5? The answer is 0. The constant multiple rule, what's the derivative of 5x squared? Well, it's 5 times the derivative of x squared. So pull those constants out in front. Addition and subtraction we could separate. Multiplication, that's where we said it was 1d2 plus 2d1. The quotient rule is where we said it's low d high minus high d low over what's below squared. The power rules, bring the power down, subtract 1. Or bring the power down, same thing, subtract 1, but remember to multiply times the derivative of the inside. Really important there. Chain rule is the dy dx equals dy du dx. Same exact thing, the chain rule, the power rule is the chain rule. The chain rule is the power rule. It's just the chain rule is the formal definition of it, and the power rule is the application more so of it. So make sure you know all of these rules. These are the rules that I would be probably putting on my note card if I get a note card, but you're going to reference them numerous times, quite honestly. Hopefully you don't reference them numerous times. Hopefully you commit each and every one of these rules to memory.